And if there's one thing that is absolutely certain, requirements will change no matter how well you design, no matter how good you model. Your requirements will change, and sooner or later you will face this one requirement which will break your architecture. State-based systems are doomed to fail. That's a bold statement. Let me elaborate why I think that's still true. Let's talk about the state trap, and we use a concrete example for this. This is Jeff. Jeff owns a law firm. He's a lawyer. In law firms, you handle a lot of cases, sometimes hundreds, sometimes thousands, quite a lot. In every case, you have different persons which are involved. This can be clients, this can be opponents, this can be insurances, this can be anything. A lot of people are involved in different cases. Most developers will immediately think of a diagram like this. Looking at that, we have law firms which reference many cases, and the cases again reference many persons. Simple. And most developers will also immediately think about the relational schema. Which tables are involved? We have our law firm table, we have our cases table, we can set a few foreign key constraints, we have our persons table. These three tables are enough to get started. Let's build this thing state-based. So we start with a simple use case, we add a few persons here, all very simple. But then we realize a person is not a person. Wait a second, what does that mean? Well, looking at the persons, we see the different types have very different attributes. Private persons have a name, have an address, have a birth date. But a law firm has name, several addresses, a registration code, but no birth date. And then we have authorities, which have a name and an address and maybe a contact person. So all these persons, they are very, very different. But the question is, how do you model that in your relational schema? How do you adjust your tables? Well, let's see. To add a lawyer to our table, we would have to add a few new columns here. And the problem is the registration number is only available for lawyers, so we need to make it nullable. It's just some nullable columns, not a big deal. I think we can deal with that. Let's hook up our object-relational mapper. Let's define the role, for example, as our discriminator, and let's put up this beautiful object model where all the attributes are set, and let the object-relational mapper do the heavy work and map the relational table to our objects. Easy. What you don't realize is every nullable column is one more crack in our architecture. The more cracks, the more fragile our architecture will be. Because over time, more and more of these different person types are attached. And then we realize that we cannot even use the role as a discriminator, because we can have persons in different roles which map to the same person type. So we need another type which tells us which type of person is this actually. Even more cracks in the architecture. But the next question that comes up is, where do we put all the validations? Because the database can no longer help us. For some persons, columns are nullable, for other persons, they aren't. Just put the validations in code. Not a big deal. I think we can deal with that. And over time, our table grows and grows and grows. Well, the question is, can't we just define dedicated tables per person type? Wouldn't that be simpler? Something like this. That doesn't look too bad now. The table schema matches exactly our object schema, so we have one model that we have to deal with. That's good. But making these small adjustments makes other use cases much more difficult. Because now, if we want to showcase a list of all persons for a case, we need to join all these different tables. That's far from ideal. Or could we just define a few tables per use case? So for example, if we have a person details page, we could have a person details table. The problem is now we need to synchronize all these use case specific tables. How do we do that? Couldn't we just define database views for that? Well, we could have different views on our persons table. The problem is all these views are coupled to our persons table, and this limits us in the way we can evolve our database schema. We cannot freely change our table because all these views depend on our schema. All these approaches aren't bad. They simply don't really solve the fundamental problem we face. The big problem here is the state-based approach. State forces us to think in one model, one state for all of our use cases, which is simply not the case. Our system has many different states and many different use cases. State-based development forces us in one specific direction and removes the flexibility. We cannot go back. Honestly, why is this so hard? The problem is, we are operating under wrong assumptions. There is no state in our system. There is many states, many different use cases. And the problem is, the bigger our state, the more likely it is affected by changing requirements. And if there's one thing that is absolutely certain, requirements will change no matter how well you design, no matter how good you model. Your requirements will change, and sooner or later you will face this one requirement which will break your architecture. This is exactly where domain-driven design starts to help. There are a lot of things in domain-driven design. I love domain-driven design. It's the foundation of good and solid software engineering, but it doesn't solve the state-based problem. No matter how well you design, how well you work, how good you apply domain-driven design in your state-based world, it won't solve your problems. It will help you to postpone the problems. If you still operate in a state-based world, sooner or later there will be so many cracks in your architecture that you simply cannot continue. And then you talk about rewriting the system. What we're doing is we're trying to reduce the probability of failure, but that is not how I want to work. I want to increase the probability of success, and that is a whole different story. Well, in the next few videos, I will talk a little bit about how I think we should design systems that are designed for success. And if you want to know more about it, I wrote a whole book about this process. It's called Understanding Event Sourcing. It's not only about event sourcing, it's about this whole process from idea to code and production in a system that stands the test of time and allows you to keep it maintainable even for years if you need.